Hi, everybody. Andy Thompson here from CyberArk Labs, and I've got something really exciting that I can't wait to show you today. Today, we're going to be playing around with some malicious software. I think we're going to be playing around with some ransomware, crypto jackers, credential harvesters. We'll do a little bit of DNS poisoning in there as well. But more importantly, I'm going to show you how CyberArk's Endpoint Privilege Manager can protect against all these different attacks. So grab some popcorn, take a seat, and enjoy the show. All right, let's get started with exercise one. Exercise one is all about ransomware, and that's what we're going to be executing here. But before we do, let's get a lay of the land and see what we're working with. So, in our personal folder, you'll see that we have several Microsoft Office documents. We've got a couple Word docs, an Excel spreadsheet, a PowerPoint. Again, this is what we're going to be ransoming in just a moment here. So what we're going to do is we're going to open up a macro-ridden Excel spreadsheet that's going to kick off our Shiva ransomware. So let's give it a look. Totally not ransomware, or is it? Let's see. Double click it, give it an open. Oh no! Our files have been infected with ransomware. Tells us to go check our personal folder. So let's go back and take a look. So going back to our personal folder, you can see, aha, it has indeed been encrypted. Let's see, let's open up the ransomware message. Yes, we have been encrypted with the Shiva ransomware. We must send them some Bitcoins or our files would be encrypted forever. Oh no, whatever shall we do? What we're going to do now is before we jump into EPM, we're going to go run that file decryptor. So then when we rerun the ransomware, we'll see how it's blocked. So we'll go ahead and run our decryptor here. So in the ransomware folder, I have this decrypt script. It launches our decryptor, and we just have to enter the super complex decryption private key, which is 1337 for you elite hackers out there. All right, so we now have recovered our files. Let's go take a look just to verify. And there you have it. Okay, our files are back. But let's now implement our default policy out of CyberArk's EPM. So what you got to do here is go to the policies side tab here, expand it, and you want to go to default policies. In the default policy section under privilege management, you'll see this rule here, protect against ransomware. All you got to do is go from oft to restrict. Go ahead and click yes to confirm the settings. And now our policy has been successfully set. Now we just need to wait the 5 minutes for the endpoint to pull down the latest policies. But I'm going to show you a little trick real quick to have it pull it down instantly. All you need to do is right click on the EPM icon in the task manager and select request settings. Select yes to confirm, and it immediately pulls down the latest and greatest policies. So what you're going to see here is actually something rather interesting. The ransomware is still going to run, but the ransomware policy is actually protecting the file types themselves. So, for example, Microsoft Word, that Word.exe, that's the only process that's allowed to write Word documents. Same thing with Excel and PowerPoint and really any sort of file extension that you define. So in this circumstance, we're going to run the ransomware. It's going to execute, but it can't encrypt the files. So if you don't believe me, let's give it a run and see what happens. All right, so we relaunch our ransomware file. You can take a look. It actually did run. See, we got the ransomware message and everything, but it's been restricted. Keyword here being restricted. So let's go ahead, close this out, take a look, go back to our personal folder, and you'll see, hey, look, even though the ransomware ran, we still have the ransomware message here. You can still see that our password, not our passwords, our files are not encrypted. That's CyberArk EPM's ransomware protection policy in action. Pretty cool, right? All right, moving right along, let's get started with exercise 2, preventing internet downloads. So what we're going to be doing now is playing around with a fun little program called XMRig. And if you're not familiar with XMRig, it is a cryptocurrency miner. It is utilizing either your graphics processing unit or your CPU to mine any sort of different types of cryptocurrency. And what we're going to be mining today is a crypto called Monero. Now, Monero is being more adopted by malicious actors in the wild today because, as compared to Bitcoin, which is a pseudo anonymous cryptocurrency, Monero's ledger is completely encrypted and therefore completely anonymous. And so that's why you're seeing more and more criminals using it. So what we're going to do is we're going to download the XMRig application. We're going to watch it do its dirty work and watch the system completely cap out in its CPU power. And then we're going to relaunch EPM, and we're going to set a policy to block any process downloaded from the internet and protect against this sort of crypto jacking attack. So let's get started. So in exercise 2 here, see we have this step 1 bat. All that does is just download the XMRig application from the Chrome, launches it, and then opens up the task manager so we can see the system processes. So as it's doing its thing, we'll let it go. And there we have it. Let's take a look at the system performance and watch the CPU utilization. See how it's completely pegged out at 100%? It's going to completely stay that way until this application is stopped. So let's go ahead and stop it, and then immediately watch how the CPU utilization goes right back to normal here. So the only way that you can really detect if a crypto jacker is running on your system is, 1, if your system is going completely slow and your CPU is completely pegged out. 2, your system may actually be running physically hot, or if you're running this resource up in the cloud, you probably won't know until you get a gigantic bill from AWS or Azure or GCP too. But anyway, let's go ahead and use CyberArk's EPM to protect against downloading these malicious programs, okay? Let's get started. So we'll jump into EPM here. Let it launch here. There we go. And what you'll see is we'll go back to those default policies I showed you earlier. We'll go here to default policies. And rather than protecting against ransomware, we're going to enable this policy, controlled unhandled applications from the internet. So let's just go and set that to block, confirm our policy. We'll pull down the latest policies from the server so it's instantaneous. And now let's go back and rerun that program here. We'll just do step 1 again. Watch what happens. It downloads XMRig again. It's going to try to launch it. And watch what happens this time, folks. Take a look. Application blocked. It was unable to run the XM application because it was downloaded from the internet. So that's really how easy it is. By just flipping a default policy switch, you're able to protect your organization from unhandled programs downloaded from the internet. Again, pretty cool, right? All right, moving right along to exercise 3. As you saw in exercise 2, you can download a whole bunch of nasty code from the internet. And I'm going to show you real quick another piece of code that we cobbled together. And then we're going to show you how we can safely deploy code to our end users. So before we do that, let's install our VLC media player. You double click on this. We download it from the internet here, and that certainly doesn't look like VLC. That looks like Rick Astley. Yes, we have been rickrolled, and that's minor compared to what a real malicious actor might do. So what we need to do, again, is set that block unhandled processes downloaded from the internet. But again, we need to create a way to safely deploy programs to our end users. So let's show you how it's done. So back in the default policies here, we're going to go change controlled unhandled applications downloaded from the internet from off to block again. All right, so now our Rickroll won't work anymore. But again, we need to be able to safely deploy programs to our end users, right? So this is where we're going to create a trusted source policy. So you go ahead and click on policies here. You're going to go to create advanced policy, and select Create Trust Policy. All right, so from here, you can do a lot of cool things. We can select the Windows platform. And what we're going to do here is change the action from elevate if necessary to just explicitly allow. So whether it requires administrative privilege or not, it will automatically elevate to admin rights and run. And then we can take a look at the different type, how it's going to be trusted. You could select installation package, the software distributor, the URL, the signature. But what we're going to do is the network share. This is a real easy way to go about doing it. And so what we'll do is, again, select allow here and click continue. What we'll do is we're going to specify a SMB share that only the programs in that folder are allowed to execute on the endpoint. So what we'll do is go whack EPM WKS01/IT share. What are we going to call this? Let's call it IT share. And then click create. And there we have it, folks. So now you see that we have our IT share policies created. And let's go put it to the test, shall we? But before we do, we always got to pull down the latest and greatest policy settings. All right. So let's go ahead and try to rerun our Rickroll and see what happens. As you can see, because it was downloaded from the internet, it is blocked. That's good, right? So now let's go to our IT share and try to run the correct version of VLC. So here we have our network share. We have a bunch of different applications, but the one I'm concerned about here is VLC. And if you'll notice, it's got that little itty bitty shield right there. That denotes that it requires admin rights to run. And so although our user is not an admin, watch what happens, okay? So we double click on it. It's going to ask us to install here. Yep. And away it goes. It's going to automatically start installing our software. That's all there is to it, folks. I don't have to go through the whole process here, but suffice to say, if we've got to this point, the executor or the executable was able to launch and the installation is underway. And that's how easy it is to create a trusted source within EPM. All right, folks, moving right along to exercise 4, we're going to be talking about credential theft protection. Now, password scrapers, credential harvesters, whatever you want to call them, these are nasty little buggers. They do as exactly what they say they do. They scrape passwords from web browsers. Chrome in particular is a particularly weak web browser when it comes to the storing of passwords. We just saw recently with a large IAM vendor where the Chrome policy of synchronization on browsers led to a very sensitive service account stored in Google Chrome's password manager was synced from a corporately managed asset off to their personal device. And from there, the attackers were able to extract this password and cause a whole ton of chaos. And what's really scary about this is because it was all done as a standard user. Now, Chrome does try to protect this password file by encrypting it, albeit extremely weakly. See, Chrome uses what's called DPAPI encryption to protect that password file. But it's incredibly easy to access because, one, if you pop the domain controller, you get the master DPAPI decryption key. So if you compromise the domain controller, you have access to everyone's password file on your domain. The other way is much more easy. By just simply compromising that single endpoint, that decryption key is stored as an environment variable running on that machine. So again, it's incredibly easy as a standard user to read the file, pull the decryption key, decrypt the file, and spit out the passwords in clear text. So that's what we're going to do. I'm going to show you an auditing tool called Chrome Pass. This auditing tool will, just like I said, take that decryption key, use that to decrypt the password file that's stored on disk, and spit out the credentials on screen. So let's give this auditing tool a crack and see what happens. So here you have it here in the Lab 4 folder. We just give it a double click and boom, right there we have our URL, our username, our password, everything we need to compromise any of those websites. Pretty nasty, right? So let's go use EPM to protect Chrome because Chrome isn't doing a good enough job at protecting itself. So what we're going to do here is jump right back into EPM. Rather than going to our default policies, we're going to go to the policies button here, and we're going to select the privilege threat protection policies. Now, there are a ton of out-of-the-box policies that we can activate, but really, for this exercise, just going to mess with the first one here. So we'll expand the browser-stored credentials theft group here, and the very first one is Chrome credentials theft. It's currently set to inactive, so let's activate it. So once we go here, we set that to block, click yes, and there you have it, folks. Our policy is enabled. All we need to do is let the policy pull down, and we will try rerunning the password scraper and see what happens. So let's go and launch our Chrome Pass exe again and see what happens. See if it can decrypt that file. Oh no, nothing is showing up on screen. So the Chrome Pass executable was able to run, but it was unable to read that Chrome password file. That's exactly what we want to see if we're trying to defend the Chrome browser. So that, folks, is how EPM can protect Chrome when Chrome's not doing a good enough job on its own. All right, folks, we've made it to the end of our exercises. Number 5. In our 5th exercise today, we're going to demonstrate DNS poisoning. And more importantly, I'm going to show you how we can easily import policies that have already been created for EPM, whether you're promoting them from your QA environment into prod, or you're downloading policies from the CyberArk marketplace to easily activate in your environment. There's a lot of reasons why you would do this, and I'm going to show you how first, okay? So the first thing we're going to do is go to Amazon.com. All right, so I've already created the shortcut here. We're going to Amazon.com, and what do you know, folks? That ain't Amazon.com. This just happens to be the Hacker's Manifesto, written in 1986 by the Mentor. You may have heard of the, yes, I am a criminal, my crime is that of curiosity. Well, that comes from this manifesto right here. But again, this is not Amazon.com. We want to figure out why this is the case and fix this. So let's go in and take a look at our hosts file. This is the file local on the machine that will allow you to route certain websites and things to certain IP addresses. And lo and behold, somebody has poisoned the host file with this line of code. Instead of Amazon going to the proper IP, it is being rerouted to this IP address. So the way to resolve this would be to simply remove this line. So let's go ahead and do that. Now, what you'll notice here is, as a standard user, we only have read access to the host file. We do not have write access. So if I go ahead and try to save this file, it's going to send a save as prompt because we can't save it as host because we're, again, a standard user. Let me show you and prove it to you. Click save. It says, hey, you have to be a local admin. You don't have permissions to do this. So this is where we're going to import a pre-existing policy that I've already created and show you how easy it is to do. So all you got to do is jump back into EPM, and rather than going into our application policies, we're going to go to user policies. This is where we're going to import this policy. All you got to do is go to the 3 dots here and go to import policy. Select the browse button, check out the folder 5 here and select the EPMP, that's EPM policy file. Go ahead, open that up, import it, and you'll see it right here on the screen. But take a look, it's not yet active, it's set to inactive. So what we'll do here is click the buttons, select activate, and there you have it. All we need to do now is pull down the latest and greatest policies here. And let's go back and try to edit that host file, okay? So we go back in here. Our file line is still there, so we'll just remove that. Again, hoping that the policy works, we should be able to save the file this time, right? Hey, look at that. We actually were. So if we go back to Amazon.com here, watch what happens. Oh, reload it. There we go. No longer are we DNS poisoned. We were able to actually go to the correct website. And again, it was incredibly easy by just importing that pre-existing policy. There you have it, folks. We just ran through 5 simple exercises demonstrating the incredible capacity of CyberArk's EPM product. And again, we just touched the tip of the iceberg. I mean, ransomware protection, handling downloaded processes from the internet, password scraping. I mean, there's a ton of stuff that we showed today, but there's so much more between the loosely connected device password rotation capability, the threat deception capability. Again, there's a ton of stuff. Zero trust. There's a ton of stuff that we didn't cover today. So if you really want to see more about what this product can do, reach out to us. Sign up for that 30-day free trial. Give us a call. We'll go through a more extensive demo. But again, CyberArk's EPM product is an incredibly powerful tool in protecting your endpoints, but almost more importantly, your server infrastructure as well, because you've got least privilege, application control, password management, threat deception. There's so much more that you need to see about this product today. But unfortunately, I've taken enough of your time today. So with that said, I hope you learned something. I hope you were entertained. And thanks for watching my session today. Thank you so much.